All right. We will go over the library of functions stuff tomorrow. So when transforming a function, we can have a blank, blank, and or blank. What are your different kinds of transformations you learned about in math 2? Okay, that's with shapes, not with functions. We can't rotate a graph. A shift, I love that. So that's called a translation. Extra credit, Brody, good job. What else can we have besides a shift? A what? Oh, good. Okay. There's a word for stretches and compressions. Those go together. There's a word for it. Do you remember in elementary school when you would make a shape bigger or smaller, what that was called? Nobody? A dilation? Does that ring a bell? Okay. Dilations are for stretches or compressions. Very good. Extra credit, you too. Stretches or compressions. And then what's the last one? Very good, Oswald. Reflections, which are just flips, right? All right, so we can have shifts, stretches, compressions, reflections. Do you guys remember that from math 2? Yes? Y'all got to participate with me. All right, so let's see how much we remember. What does the A represent? Okay, good. Very good, Brody. Sorry, it took me a second to hear what you said. So your A is your dilation, your stretch, or your compression, right? So when A is bigger than 1, what did we do? Stretch. And you guys need to say vertical stretch. Why do you think I'm making you say vertical stretch? Because tomorrow we're also going to learn about horizontal stretches and compressions. And yes, they can happen at the same time. We'll talk about that tomorrow, okay? What about if A is a fraction? Now keep in mind, I did not say negative. If A is in between 0 and 1, meaning it's a fraction, what do we have? Very good, a vertical compression. So let's see how good your math 2 and 3 teachers were. When A is a fraction, why is it a compression? What happens when you multiply by a fraction? Can you say that again? Your original number is going to get smaller, right? Everybody's with me? So when we press a graph down, we are making it smaller. When we stretch a graph, look at my hands. When I press it, I'm making it shorter. When I stretch it, I'm making it taller. Does that make sense? Okay, I'm going to show you in a second, but me and Miss Allred used to always joke with each other. She would always say when she stretched a graph, it looked like Miss Poole. She tried to roast me because I'm built like a beanpole. And I was like, that's fine. When we be pressing graphs, they look like you. Dang, shots fired. All right. Stretches, compressions. What does the H do on the inside? What kind of translation? Good, KJ. So this is your horizontal shift. And you can call it a shift. I'm totally fine with that. And what is special about our horizontal shifts? Y'all are like, I don't know. Please tell me. You do know. I'm going to get corny. Translations are my ish. Math 2 is my ish. That is my favorite subject to teach. Always has been, probably always will be. So when we do stuff like this, I absolutely love it. So your ex, girlfriend or boyfriend, why are they your ex? Okay, because you broke up. But why did y'all break up? Oh, cheaters. I had somebody cheat on me in high school. It's fine. I slashed his tire. That's a whole nother story. Your girl is crazy. Don't cross me. He deserved it. So your ex, boyfriend, girlfriend, whoever, they are your ex because they probably did the opposite of what you wanted them to do, correct? And if they didn't do the opposite of what you wanted them to do, then you did the opposite of what they wanted you to do. Does that make sense? So if it says minus in here, where are we really moving it? To the right. If it says plus in here, where are we really moving it? Think about your ex. Your ex always did the opposite of what you wanted them to do. Does that make sense? So I need you to remember that your horizontal shift is always going to be opposite. Y'all are going to have to get used to the corny. It will help you remember it, hopefully. If it doesn't, then it wasn't a good analogy. What's the K do? Good. KJ's like, yes, I got this. That's your vertical shift. So I heard you guys say up or down, right? Does the vertical shift do the opposite? No, it does whatever it says it's doing because it is not your ex. Capiche? So we remember doing this? Can I go straight into an example? I love it. Okay. So example 1, I want you, and I'll do this first one with you, but then I'm going to turn you guys loose on one, okay? So I want you to list all the transformations of y equals all right, I typically do not do hand raising in pre-cal because, especially because there's not that many of y'all. So talk to me, what kind of transformations do we have in this function? From the parent function, where did we move it? Oh, I love that. Vertical compression. And you can just write vertical compress by 1/4. Make sure you put that factor. That's good. Vertical compress by 1/4. Chris, can you see okay? Okay. What else do we have? Good. Right 3. You can literally say shift right 3. Remember, if it's inside with X, it does the opposite. Your X does the opposite. And? Yes. And we also shifted it up 3. Easy or hard? Cool. You got a whole section of this on your test. Oh, I'm sorry. What did I write? 3? Thank you. I told you, you got to fix me. There we go. Was that you that said 3? Who said 3 like that? Okay. Whoever said it, they said it in a funny way. All right. You guys try this one. It does say negative too. Does it does. You already done? Okay, you must have had a good math too, teacher. Eric, tell me a transformation. Very good. He said vertical stretch by 2. I need you to not put -2. If I told Drake I was going to stretch his arms by -2 units, does that make sense? No, you cannot have a negative scale factor. So while we're on that subject, you guys tell me, what does the negative do? Because we haven't talked about this yet.
Reflection
Very good. What kind of reflection?
of the x-axis.
Good. Over the x-axis, or you can say vertical, either one. Because think about it, the x-axis is here. So if you flip it over x, you're flipping up and down, right? So this is a vertical reflection. Don't tell me it stretches by a factor of -2. That's not what it does. The negative just means we reflected it, okay? You can also say, like y'all just said, over x-axis. Very good. What else do we have going on? Good. Left 3 and down 1. Do we feel okay with listing transformations? Everybody feels okay with that? Okay. On your homework, I'm not done, so don't start getting excited and packing up. On your homework, there's a section where I give you the transformations and you write the equation from those. Does that make sense? You should be able to do that, so we're okay to move on. Okay. The part that I don't think we know how to do that I want to get into today, because we don't have time to get into all of it, I planned too much, and that is okay, is how to tell the transformations from a graph, because this is usually not what y'all remember from math. I guess math too. So I want you guys to graph this with me. Make sure I give myself enough room. Ooh, that is crooked. I hate drawing. That is so ugly. Okay. So a point here. I'm really sorry my picture is not cute. I'm doing the best I can with the talents that the Lord gave me. Drawing is not one of them. All right. So this is the graph they gave us. We need to write the equation and state the transformations. If you're looking at the ordered pairs, trying to figure out where they're at, it's -2, 0, -4, 0, and -3, +2. -4, 0, -2, 0, and then -3, +2. All right, are we ready to try this one? Yes? Okay, what kind of graph is this? What's the parent function? A quadratic. So we know that it should be something x squared, right? Okay, so I'm going to go ahead and put y equals, leave myself some room, and x, leave some more room, and a squared, because I know that it is quadratic. Are we okay with that? Okay, now let's talk about quadratics. Where do they normally start? Where did all of our parent functions normally start? 0, 0. Is this one at 0, 0? Is the vertex at 0, 0?
No.
So where did I move it? Where's it at? Left how many? 3 and up 2. So I'm going to go ahead and write those here. We're shifting it left 3, up 2. So where would those things go in our equation? Oh, good. I heard +3 because it does the opposite, and +2 on the outside. Okay, good. Now, what else do we normally know about parabolas? Where did our parent parabola open? It was concave up, right? Where's this one facing? Which means we did what? Vertical reflection. Very good. Do you guys see how I'm just using the graph to figure out what we did to the equation? So I can write it? Yes. Okay. And then there's one more thing we have to check for. What's the last thing we have to check for?
Dilation.
Good, a dilation or a stretch or compression. So don't write this, you do not have to. But our parent table from yesterday was -101, right? And then on this side, we had 101. So do you guys notice on both sides, they are 1 unit away? Does everybody see that? Okay, we always start with our x's. That's why they're on the left. So look at me, watch what I'm about to do. When I go over 1, because do you guys agree that these other two x values are 1 away from the vertex? Does everybody see that? So when I go over 1, how many does this go down? So did we stretch or compress it? By how much? Very good. So there should be a 2 out front. You always go over 1 from that vertex. However many you go up or down, that'll tell you your stretch or compression. Are we okay with that? Now, I'm thinking you need me to do one more because a couple of you look confused. Yes? Okay, I'm going to do one more. We will finish these tomorrow. I do have time, so don't pack up on me. You need to write this down. But this should be enough for you to at least attempt all of your homework. And it's not a hard homework. There's not a lot up there. And I think I'm going to go rogue and not go off the example that I have on my paper. We're going to do a different one. Graph this function for me. Does anybody need me to call out the ordered pairs? Will that be helpful? Okay, the ordered pairs are 2, -3. Then the next one is 3, -2.5. And then the last one is 6, -2. Are we okay? All right, what kind of function is this? Good, square root function. It looks like half of the u, right? And it's sideways? Okay, good, square root function. Where should a square root function start? 0, 0. Where is this one at? Okay, it goes where to? Right 2 and down 3. So we know our transformations go right 2, down 3. Move that so y'all can see it. And then let's talk about our square root function. Normally it does go up, correct? Because the bigger the number, the bigger the square root will be. This one is going up, right? So did I reflect it? No, if I reflected it, it would be going good. Does that make sense? So there's no reflection. The only thing we have left to check, hang on, is a stretch or compression. So look, when I go over 1, how much does this go up? 1/2. So we did what to it? Compressed it. Does that make sense? Try all of your homework. It should not take you long. If you need my help, hop on Zoom between 3 and 4, or you can message me outside of that and I'll respond, okay?